So how many of you have clients that are frustrated that their neighbors can spread manure and they can't? I'm surprised not every hand went up. So I'm not talking about winter application from a regulatory perspective. I'm going to talk about winter application in a more general perspective. And I do have handouts. A couple of the slides are in the wrong order. But basically just talking about some of the agronomic and environmental pitfalls. And maybe just some of the things that we can talk to our clients that don't have a nutrient management plan and are starting in the winter under less than ideal conditions. Now, wouldn't it be nice if we could regulate common sense? But if we could have just one rule that said, if you can apply the manure and incorporate it the same day, it's great, but if it's on snow or frozen ground and it can't be incorporated, there's some pretty big danger signs. And those are some of the things we're going to discuss. So winter application, the subtopics that I want to cover are the environmental part of winter spreading, the economic part of winter spreading, and the social part of winter spreading. In the social part of winter spreading, any of you that have non-farmer neighbors that like to live in the country and just love a winter's day when you've got that pristine snow and it looks clean and it looks white and it looks bright, and then all of a sudden you see a field that's been covered with manure. And it just ruins that nice look. That's part of the social problem. And it might be done under all the right conditions and there might be no environmental issues, or there might be, but they don't get that. They just see dirty snow. And sometimes dirty snow might just be wind erosion on top of snow that looks like manure. Sometimes it's hard to tell. But dirty snow is something we don't like. So I'm going to ask you, why do farmers spread manure in winter?
Because they're full.
Because the storages are full? Okay. What other reasons? Bored? Okay, they have a lot of time on their hands.
Not muddy, it's clean.
Say what?
Not muddy, it's clean.
It's not much. Okay.
Clean going.
Field conditions,
Job is
relatively
done
good.
before spring.
One less thing to do ahead of spring.
Ground's frozen, so less compaction issues.
Okay, that's a big one.
Yep.
Yeah. So lack of storage and or lots of rain and or poor planning. And I'm going to say in a lot of situations it's probably poor planning. Because I've seen farms where there's 365-day manure storage and it's full. So we're going to talk a little bit about that. Convenience, a job done now is one less thing that I have to do in the spring. Especially when we don't know what those conditions are going to be in the spring. So if we've got frozen ground now, we're not going to do the compaction damage. If it's flat, we're not going to have any pollution from that. That's a lot of farmers don't see the problem. They don't get how phosphorus potentially moves or how nitrogen moves. Preventing compaction, I think that's a huge one. I think that's a far bigger issue than what people realize, and I'm going to show you that in a minute. Maybe a different way to think about manure application. And I'm going to say that when it comes to government talking about regulating winter application, it would be far more beneficial, this is my own opinion, it would be far more beneficial if we talked more about how can we increase the application during the growing season. What technology is available, what technology can we maybe provide grants for or whatever to get more application in the growing season, into growing crops, forages, after wheat harvest with cover crops. And I'll talk a little bit more about that afterwards as well. So the economics, what does winter spreading cost? And some farmers are going to say, well, it costs me less just to apply manure in the winter than it would other times of year when I look at some of the other things around my operation. For example, there's less demand on my labor and equipment compared to in the spring. If in the spring I'm trying to get the field work done, I'm trying to get my crops planted so that I'm not going to lose yield because I'm planting the corn too late, but I also have to get the manure out. And any of you that are in that Niagara area, last year there was basically 2 days between soil conditions being too wet and being too dry for proper corn planting, soybean planting. And if you had to apply the manure, that was a huge cost in yield in those areas. Less compaction, opportunity for timely planting of crops. Those are a couple. But there's also some other economics. And I'm going to ask you this question. If you had your fertilizer applicator come and spread a half MAP, half potash to a field in preparation for spring, they're going to do it in the winter because the custom applicators have time then too, like the fertilizer applicator. And you're paying basically $550 a ton for this fertilizer, or $28 per 100 pounds. And then in the spring, in June, when the corn crop was planted, somebody gave you a map that looked like this, where all the nutrients were concentrated in those black areas. There was no nutrients left in those red areas. There was some movement of the nutrients in those yellow areas, and in the green areas, probably pretty much the nutrients that were applied. How do you plan fertilizer application, or how do you use the fertilizer that was applied if this is what it looks like? And that's not counting the amount that went off in the water into the creek. How does a farmer compensate for that kind of fertilizer application? And my question is, if one of your clients had this kind of a map that showed what the fertilizer distribution was in the field, would they pay the bill? So if they're not satisfied with that with custom fertilizer application, why would anybody be satisfied when that happens with manure application? Because the economics are huge.
Because
It's just poop, yeah. Perception problem. So that's I think that's one of the things that we have to do a better job of. And Dale and I have spent our career trying to show people the value of manure, economic fertilizer value, and it's increasing because there's value to the organic matter in that manure, there's value to the sulfur in the manure, and we don't even count that, or some of the micronutrients, we don't even count that in our value evaluation. So we have to do a better job of that because farmers get it with fertilizer because they're paying that fertilizer bill. Maybe they need a similar kind of a bill or evaluation when it comes to the manure that was applied in the nutrients. So they may say it's just poop and yeah, I've applied it when I'm not going to cause compaction, I'm not going to cause other things, but I might have created a whole new problem and it's going to cost me money, even though I don't see it. And then in the future, this could come back to haunt as well, because if you've got areas of the field that have high phosphorus levels, is that going to limit the application if your phosphorus fertility levels are too high in the field? So I said I was going to talk a little bit about compaction. And the main reason that I want to talk a little bit about compaction is because I think this looks at economics in a little bit different way. And you might not agree with me, but this is just the way I look at it. So I heard Scott Shearer from Ohio State speaking about the cost of compaction. And he talked about doing a study in Ohio, and 44% of the field was tracked spreading manure. And in those tracked areas, there was a 6 bushel yield difference when the soil conditions were dry, where there was the track compared to where there wasn't. Just higher tracks, not the other kind of tracks. So 6 bushel yield difference. But where there was wet soil conditions, so applied too early, or in wet soil conditions, there was a 27 bushel yield reduction. So a 27 bushel yield reduction on about 44% of the field, and if corn costs $4.50 a bushel, it's about a $50 per acre yield loss just because of compaction. If I can put that $50 onto my wheat crop because I'm harvesting it in the summer and then I have time to apply manure and maybe some cover crops, improve my soil, do things when I've got a little bit more time, maybe that's a different way we have to look at our crop rotations to get more manure being applied in more ideal soil conditions. Farmers say, oh, I can't afford to plant wheat because wheat just doesn't give me enough return. But if I look at labor, if I look at opportunities, if I look at compaction, look at the economics a little bit differently, then maybe I can improve my soils, have less compaction, and also benefit my soils. Just a thought. So I'm going to go a little bit into some of the phosphorus. How many of you have heard this phosphorus spiel more than once already? A couple of you. Several of you. Okay, well, I'm going to go over it again. So, this is a picture of my field, our farm, and it's relatively flat. There's a couple of areas where there's a 3 to 5% slope, but it's pretty short. But this was a picture I took on March the 4th, a couple years ago. The ground had been frozen, and then it was a warm period, and we've had lots of those this year. Warm period, the ground was still frozen, and it was raining. And the trouble is that when we have those type of conditions, and we've got manure on the surface, or we've spread manure on the surface, we have maybe a centimeter or two that's thawed at the top of the surface, but below that it's still frozen. So there's no infiltration capacity. And if there's no infiltration capacity, that means we're not going to get any tile flow if it's frozen. So it's going to take the path of least resistance. And the path of least resistance is going to be those low areas where water always flows in a big storm. If any of you heard those thunderstorms this morning and saw the water running down the fields, those areas. And it's going to take any soil that doesn't have good aggregate stability, or doesn't have residue cover, or doesn't have root foundation, it's going to take it with it. And any of that soil that has a fair amount of phosphorus, or phosphorus that's on the top that's just soluble, is going to move with that water. Some years we've got these conditions more than other years. This year there's probably a lot more through tile runoff and surface flow. But it's not only the particulate phosphorus that moves. It's not only the phosphorus that moves with the soil. It's also the phosphorus that just sits on top and moves with the water. So when we talk about materials, whether it's fertilizer or whether it's manure or whether it's whatever material we're spreading, when the ground is frozen, there's no opportunity for infiltration. There's a lot of farmers that think, oh, well, if I put it on the snow is going to melt nice and slowly, and it's all going to infiltrate in as the soil thaws. But how many times have we seen thaws without rain? I can count a couple, but not many. Usually there's rain with it, rain events. So nutrients on the soil surface will move with the soil water, and soil with low aggregate stability will also move with the soil water. So basically, materials containing phosphorus should not be applied unless they can be incorporated the same day. And even then, if there's risk of erosion, there's still the potential for some phosphorus loss. So there are people talking about trying to put in regulations, and there's some people that make some pretty neat statements that would make some of us a little bit angry. The loss of nutrients, specifically phosphorus, is agriculture's issue to manage. So they're talking about non-point pollution. Basically, there's a lot of phosphorus coming from a lot of acres compared to sewage treatment plants or specific places. And so the comment is, if we all contribute a little bit, then we all have to do our bit to create change. There's other people that are saying, well, my phosphorus fertility levels are low, so I'm not contributing much from my non-point source area. But the farmers that have really high fertility levels and are applying manure, well, they're contributing a lot more, so they should do more. It's not true. It's everybody needs to understand how phosphorus works in the environment and what can we do around that 4R strategy. And it's interesting because I was on a conference call this morning with Fertilizer Canada, and the retail sector, the outlets, are trying to establish 4R stewardship across the province. Because if the retail can say, we're doing our part to reduce this much phosphorus going into Lake Erie, then those are regulations that we maybe don't need. And so part of what they're trying to do is come up with a listing of what kind of management strategies are we going to recommend to our farmers around nutrient management. And it all comes down to the 4R. Basically the right source, the right place, the right time, the right way. Not always in that order. And so they're looking at how many acres can they tell the government are covering this 4R stewardship. It's not in place yet, but they're looking at trying to develop, the same as Ohio is doing. And it's a good approach, because if we can get every farmer, whether they've got manure or whether they've got fertilizer, applying manure based or nutrients based on maximizing efficiency for crop production but minimizing the risk to the environment, then we're going to see improvements. I've included this slide basically just to show that there are differences in winter weather across the province. And so we went to the Ontario Climate Normals and just picked out a couple of different locations and looked at how many days are there with greater than 0 degrees, and how many days are there where it's greater than -2, and how many days are there where there's more than 5 millimeters of rain. And this is a 30-year average. So it's going to vary by year, but it does show the difference in location. So here in North Bay, you're going to have less opportunity to apply during those winter months compared to maybe Windsor. So why are we targeting phosphorus? And this is probably a slide that you've seen before, so I'm not going to spend much time on it. Phosphorus gets measured in several different ways. And basically, total phosphorus is made up of dissolved phosphorus and particulate phosphorus. Particulate phosphorus is basically the phosphorus that's tied to soil. So it's the phosphorus that moves with the soil through erosion. The dissolved phosphorus, it's the phosphorus you can't see. It's in the water. It moves with the water, not with the soil. And it's that dissolved reactive phosphorus that's the most bioavailable. Basically, if it's in the water, the algae can use it, and that's, if it's in high amount, then it can support that algae growth and produce algae blooms. And so that's why we're looking at mostly non-season loss. And you've seen quite a few pictures like this already. But in the non-growing season, based on the MOECC water quality report and a bunch of other studies that have been done, basically 80% of the phosphorus loss occurs between October and April, end of April. 80% of the phosphorus loss during the non-growing season. And the other thing we know is we've always had intense rains that happen, but they seem to be coming more often. And this year is a perfect example of how many rain events we've had. Can you imagine if every single one of those rain events had been a snowstorm? How much snow we've had? And so this is work that was done by Chris Van Esbroek. Again, many of you have seen this. But I just want to talk a little bit about the difference between what's coming off of the surface weather compared to what's coming through tile. And so this is when the ground isn't frozen, but there's a difference depending on what the topography is. If you've got hilly soils or hilly fields like you have in the Maitland area or in Upper Thames, it's going to be quite a bit different than what you might have in Kent Essex, where it's generally very flat, long slopes. And so Chris showed in the light blue what comes off in tile, and then in the dark blue what comes off the surface. And you see where there's hilly fields, there's a lot more that comes off the surface. Where there's tile, or where it's flat, there's more in the tile. And so the other thing was, what is the relative contribution of the tile and surface runoff? And this is over a 1-year period, from May 2012 to May 2013. But it shows in that top circle, 81% of the runoff was surface runoff, or sorry, 81 millimeters. 294 millimeters was through tile. If you looked at the dissolved reactive phosphorus, about less than a quarter was through tile. More than 3/4 was through surface runoff. And if you looked at the total phosphorus, is about half and half. So the conclusion that Chris made was that the surface runoff is not the dominant pathway for water movement. It only represents about 22%, but it accounts for more than 3/4 of the dissolved reactive phosphorus. So erosion, surface runoff is huge. But even with drainage, and we've always heard that if our soil fertility levels are in check, that we're going to have that phosphorus attached to the soil particles. We're not going to get much leaching of phosphorus. We might see leaching of phosphorus as our soil test levels get higher. But one of the things that we didn't really ever consider, or we considered it for nitrogen, but not so much for phosphorus, was those macropores. And this is probably more an issue in the fall or after a dry period. But if we've got cracks in the soil or if we've got earthworm channels, then we have a pathway even for some dissolved reactive phosphorus. And so when we see reports where there's phosphorus in the tile water, that's mostly where it's coming from. I borrowed this slide from Tom Grossma, but when they did the Ontario soil test calibration for phosphorus, that's basically what it looked like. You had recommendations to about 30 parts per million, and then beyond that, you really didn't see much yield impact. But now I'm going to look at the other way, and again, I borrowed this one from Tom, for Tom as well. This one looks at the soil test level using the bicarb test and runoff dissolved reactive phosphorus. And basically what it says is if we're below 50 parts per million, we generally have lower phosphorus leaving the field as reactive phosphorus. And that as our soil test gets higher, so does the chance for runoff. So basically what this says is, and there's other charts in the states that show the exact same thing, that as our soil fertility levels increase, so does the chance for some of that phosphorus to move through the soil profile. Not as fast, obviously, as nitrogen, but it has that potential. So in other words, if we've got fields that have high fertility levels, that phosphorus should probably get moved to fields farther away for environmental reasons, but also for maximizing nutrient efficiency. I'm not going to go over this. When you get the handouts, this is just there to show how do other states and provinces handle manure application in winter. What are the types of regs? And then the one that we hear quite a bit about is Ohio. And I'm just going to, they've compared Ohio to Ontario, and I'm just going to summarize this by saying that the regulations we have in Ontario are probably stronger than the ones we have in Ohio, or not we, that they have in Ohio. It looks in some cases like Ohio is more regulated, but they've got 3 different types of regulations. One for the CAFO farms, or the really big operations that require nutrient management plans. And then they've got the regulations that are statewide. And then they have the regulations, and these are the regulations we hear the most about for that western basin of Lake Erie, which is really just a small part of Ohio. So, and even there, they do have some regulations that say you can't apply in the winter unless you can incorporate. They also have the regulation that says you can apply on 30% residue or living crop. What they don't tell you though is you can apply on that living crop even if there's a foot of snow. Which is kind of backwards, but so it's good to compare, but it would be if we had the regulation that exists right now in nutrient management planning that covered all farms, we would have a far stronger regulation than probably most of of the provinces or states. So this is a picture of a map I just took it offline this morning, of the dots where people have applied manure this winter. And they're looking at how do we measure, or how do we assess where manure has been applied? Because as we're going through the talking about regulations, one of the questions that comes up is, well, how much manure is being applied anyway? And we don't have a very good answer. We don't know. So this year there's been an attempt to take a satellite image and say, okay, can we tell from a satellite image where manure has been applied? And to do that, you have to ground truth it. So there's been, every time that no regulatory impact here. So Chris, don't look at this now. And in most cases it was done, if they needed a nutrient management, in most cases it was to a living crop where it was on 30% residue or more. But just the same, they look at where manure is being applied. And this is just some of it. This is just the ones that OMAP staff or different people were looking for. But it's more than, I think it's more than we expected. I don't know what to do with this information, but I just thought I would show you. The other thing that Ohio has, and a couple of the other, I think Manitoba is looking at it as well, is that if it's red, don't spread. They're having the weather forecast ahead of time. Now, personally, I don't think having the if it's red, don't spread type of rule in Ontario would be really that good, because first of all, how often do those weather updates get made? And secondly, if you've got a thunderstorm warning, how many times is there a thunderstorm warning and nothing happens, or it's just a really narrow band where it happens? And how often are you going to get your neighbors that don't like that you've got manure looking at that map and saying, oh, you broke the rules, we're going to call them a weed? So I like the idea of looking at the weather forecast and assessing whether there's a risk and how big that risk, and if there's a risk of rain, making sure it's incorporated immediately or waiting until it's not. There's nothing more frustrating than passing by a field in February when there's a 100% chance of more than an inch of rain and seeing your neighbors spreading manure. And it bothers me, and I understand why people do it. Can you imagine what the neighbors that don't understand manure application think? So what are some of the alternatives? And you know all of these. I'm sure you talk to your clients about these all the time. Finding the alternate storages. Well, that's easier said than done, because there's competition for those alternate storages. You've got companies that are producing anaerobic digestate. You've got people that are looking for storages for the lister-grown material, for other materials. So there's competition for those manure storages. So it's sometimes easier said than done. Build additional storage when there isn't enough. Again, that costs money, easier said than done. Giving a higher priority to proper manure management. It's probably a better solution. Trying to make manure, put that economic value on manure so that it gets treated the same as a fertilizer. Maybe if we're trying to increase the manure in the non-growing season and we're too busy, we've got too many things going on at the same time, maybe we hire out manure application to custom applicators. Custom applicators that maybe have the new technology, it's always calibrated, and they have time when a farmer might not. And what are some of the opportunities? Those of you that have taken some of the nutrient management courses that we did in the past, we always talk about what are the different times in the year where you can apply manure, or maybe apply manure. So for example, a dairy farm after forage harvest, or after wheat harvest with cover crops. And in this map they look at, okay, so there's a lot of manure that gets applied at planting time, or fertilizer in general that gets applied at planting time. There's not that much, there's some that goes on in the growing season. That probably could be expanded. But there's different times of the year, and based on, every operation is different, but based on the conditions in that operation, are there times in the year where we can apply manure, other than just after harvest or first thing in the spring? There's some neat technology coming out. There's the GPS capacity, so that we can say, here's where we've applied manure, here's where we haven't. There's opportunity coming with strip tillage. It's a fall application after harvest where it's incorporated in a strip. So there's all kinds of really neat technology coming. Drag hose systems right now, they're too expensive for most farmers, but custom applicators may be looking at this down the line, where drag hose systems can go into standing corn, turn around and do very little damage. So if we could apply more manure during the growing season into standing crops, we would not only reduce our phosphorus loss, we would also reduce greenhouse gas, nitrous oxide emissions. We would divert, this is looking at the biosolids and organics as well, but we'd be more organics diverted from landfill. If we could apply during the growing season, we would make better use of the nutrients from manure, whether it's manure or municipal organic amendments. We'd have more opportunities for synergies with crops, better root systems, more microbial activity in the soil, reduced compaction. We would be able to utilize some of that GPS technology. And one of the things that we would be doing is promoting for our stewardship, because we'd be doing more right time, right place. And we would reduce the amount of manure that gets applied to snow-covered ground. So, like I said before, it would be nice if instead of saying, oh, we're going to regulate against manure applied to snow, to say, let's try and get more manure applied during the conditions where the crops are going to utilize it better and we're going to have less environmental impact. So just, again, I included this so that you have a copy of it in your slides, but the best management practices we have for farms right now are probably in the environmental farm plan. The section under category 1 or column 1, those are what's currently regulated. So anything that we can do above category 1 is going to help reduce the amount of phosphorus or the amount of manure that moves off of soil. And that's both for solid and for liquid systems. So unless there's any questions, just an advertisement that our new agronomy guide is going to be available in the very, very, very near future. There's going to be some printed copies, but it's also going to be available online, I think for free. That part I'm not 100% sure of. And it does have updated manure sections, so there's a little bit different method of calculating nitrogen from organic portion of manure. There's updated section on soil testing, special soil testing where you've got strip cropping. So there's a whole bunch of new things. Stay tuned. And if anybody wants a copy, give the office a call and we'll send it over.